And we'll get started with measuring the standard deviation. Okay, so we're going to learn how to do the standard deviation. So yesterday we talked about the 5-number summary, and we talked about mean, and we've talked about median. And so we've talked about range and IQR, and the last measure of spread that we're going to talk about is the standard deviation. So the 5-number summary is not the most common numerical description of a distribution. That distinction belongs to the combination of mean to measure center and the standard deviation to measure spread. The standard deviation and its close relative, the variance, and we're going to talk about that too. You really, I mean, they're kind of interchangeable with themselves, but we talk about the standard deviation. They'll ask you to find the variance, and the variance is real close to the standard deviation, okay? They measure spread by looking at how far the observations are from their mean. Okay. This is basically the definition of standard deviation, how far the observation is from the mean. So let's explore this idea using a simple set of data. So in the think about it on page 50, which we didn't do, sorry, I'm trying to adjust this. Data was examined on the number of pets owned by a group of 9 children. Here's the data again, arranged from lowest to highest. So it says find the mean. How do we find the mean?
It's the average.
Yeah, so how do we find it specifically?
Add them all up and then multiply by the number.
We're just gonna add them all up. And if y'all are okay with it, I'm gonna tell you that it's 45. There were 9 children, that's what it said. So that gives us 5 is our X bar. So it says find the mean, X bar is 5. All right. So then talking about standard deviation and variance, we're gonna look at this chart. So your observations, this is what all the kids said. They had 1 pet, 3 pets, 4 pets, 5, 7, 8, 9 pets. I'm not living in the house with 9 pets. It's not gonna happen unless I live on a farm and they're all outside. Okay, is everybody good?
I'd live in a house with 5 pets.
Unless you got like, they're all fish or something, you know?
Yeah, don't you have a bunch of pets, Miss Jones?
No.
I thought you had like 3 dogs, a goldfish.
Rachel, why you stopped?
A guinea pig.
5. I have 5.
That's only 4
I guess
off.
if you had like 5 fish, 9 fish, that wouldn't be too bad. But like if you had 9 dogs, that's a lot. That's a lot of dogs in a house.
All my fish always die. I don't know why.
Get a fair fish. They live forever.
I've never had a fish.
Get a fair.
No, I do take care of them. They always just
I think my cat killed my fairfish.
Ew.
Haley came over to my house and started harassing my grandma's dog.
That sucker's name.
All right.
That's why.
Let's go through. Don't forget I'm recording this. Don't forget. All right. So we're going to talk about the deviations. That's the distance from the mean. So what this little XI is your observations from this side. So it's your observations and then X bar is your mean. So your observation minus your mean. So we're just going to go through this whole chart and do the same thing. So our observation in this column or in this row is 1. Our mean will always be 5 because that's what we found it out to be. That gives us -4. We're going to do the same thing. This was 3 minus 5 gives us -2. 4 minus 5 gives us -1, and there are 3 of those. 5 minus 5 gives us 0. 7 minus 5 gives us 2. 8 minus 5 is 3. And 9 minus 5 is 4. If you add this column up, you have 7, 8, 9 right here. Minus 3 is 6. Minus 2 is 4. Minus 4 is 0. It will always add to 0. Then we're going to do our squared deviations, and we follow the same thing that we just did, only we're going to square it. So we're going to take this number. Notice these are the same. Okay, take that number. So we got -4. And we're going to square it. Remember, that turns into a positive. We have -2 squared, -1 squared, and there are 3 of those, so I'm not going to write it all out. 0 squared, 2 squared, 3 squared, and 4 squared. If we add all of those up, we get 52. The sum of the deviations will always equal 0. These will always be different, okay? All right, so the variance. The formula for variance is the summation, or add them all up, of the squared deviations divided by n minus 1. That's the observations minus 1. So what was the sum of our squared deviations?
52.
52.
What was our n? Our n is the number of observations or the number of kids that we observed.
9.
9. So we're going to do n minus 1 or 9 minus 1. So we do 52 divided by 8, which is 6.5. Okay. So then your standard deviation, to find it, you take the square root of the variance. Now you're going to have to know that these are interchangeable. So square root of the variance is the standard deviation. To find the variance, you square the standard deviation. Okay, so those are interchangeable, and we'll do those a lot. So it's not something that you have to know in 2 seconds. Okay, this standard deviation is the typical distance from the mean. Typical distance from the mean. And so when we interpret it, I've talked to you about interpreting. When we interpret, you're going to say the standard deviation is blah, 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 which typically differs from the mean, okay, in context of the problem. And we'll write that out a bunch. Again, things that I'm just trying to introduce to you that are going to happen soon. So you need to know that it's the typical distance from the mean.
My sister called me. I didn't see. Where did you get the n was 8?
Your n is 9 because you have 9 children. Minus 1 gives you 8. The formula just says n minus 1.
Oh, okay.
As you can see, the average in the standard deviation calculation is found in a rather unexpected way. Here we go. Why do we divide by n minus 1 instead of n when calculating the variance and standard deviation? The answer is complicated, but will be revealed in chapter 7. So next semester, we'll talk about why we do n minus 1 instead of n. Right now, all they want you to focus on is the formula. Your calculator will find it for you, so it's not a formula that you have to know. What I told you you needed to know is how to find the variance from the standard deviation or the standard deviation from the variance. Okay. So standard deviation. The first thing that you're going to find is the variance. It's denoted like this, the standard deviation of x squared is 1 over n minus 1 times the sum of xi, the observation, minus the mean squared. It's the same formula, they just pulled this to the outside instead of putting it underneath. This is how you'll see it on your formula sheets, okay? When I quit being lazy and I upload them, okay? When I get there, I promise I'll put them in, okay? But that's what you'll see. Your next one is your standard deviation. Your standard deviation is just denoted by that S sub x. It's just a big curly S, nothing crazy. And you do the same exact formula, but you're taking the square root. So 1 over n minus 1 summation xi minus x bar squared. What does xi stand for? X sub I.
The observations.
Observations. What about x bar?
The mean.
The mean. What about n?
That's the number of observations.
So again, if you look at this, to find the standard deviation from the variance, we square root. To find the variance from the standard deviation, we square it. Okay, so they're back to back, just like that. So how do you find the standard deviation? You're going to find the distance. An observation is from the mean and square it. Add those numbers. And divide by n minus 1. What does step 1 and 2 give you? If I only do step 1 and 2, what does it give you?
Variance.
That is the variance. So how do I get the standard deviation?
Square root it.
Take the square root. Now again, your calculator will do this for you, so don't stress out too much about trying to find it. Okay. All right, many calculators report 2 standard deviations. Let me see, I don't think I have anything in my stat anymore. Yeah, I do. Stat calc, 1 bar stats. So this SX and this, gosh, I can't even think what that is. Anyway, those 2 right there. The 17 and the 18, those are both standard deviations. We will know when to use each one of them. Okay, so that's why it says it does both. One is usually labeled like this. That's a symbol for a population standard deviation. So this is for population. It said this standard deviation is calculated by dividing the sum of the squared deviations by n instead of n minus 1 before taking the square root. If your data set consists of the entire population, then it's appropriate to use that one. We don't typically use that one, okay? Most often the data we're examining comes from a sample. In this case, we should use the S sub x. So if we were doing this data set, this was a sample, we would use the 18 instead. Okay. Stay right here for a minute. I'm going to show you something. You'll see this denoted again. So this is the population standard deviation. You eventually will have to know the difference between these two and when you use them. This mu is the population mean. And it's mentioned that one time. But then you have S sub x, which is the sample standard deviation. And you have x bar, which we found, which is the sample mean. And typically we use these because we're talking about samples from the population. Okay, again, we'll go over all of that again. It's just kind of introducing you to it. All right, is everybody good? Next page. More important details in calculating the standard deviation are the properties that describe the usefulness of standard deviation. So S sub x measures the spread about mean and we only use this with the mean. So if you pick that your center is the mean, then your spread should be standard deviation. If you pick median, do not use standard deviation. That's all it's saying. Okay, so only use this with the mean. The standard deviation is always greater than 0. Why is that the case? How do you get the standard deviation?
It's how far something is from the mean, and it can't be like negatively far away from the mean. So, or it can't be 0 either.
Okay, but what do you do to find the mean?
Oh, you have to. Oh, you divide by the how many. I don't. Never
All right,
mind.
no, I messed that up. What steps do you take to find the standard deviation? I messed that up.
Well, you have to do the square. You have to square
Every time we square, what kind of number should we get?
a positive.
A positive. So no matter what, we should have positives. And when we take the square root of a positive number, we're going to get a positive number. So it's always greater than 0. S sub x has some units. Has the same units. So the standard deviation has the same units as the original problem. And then just like the mean, it is not resistant. So it is affected by outliers. And if you need to write that down, write that down. It is affected by outliers.
Ms. Jones, on the other side, when we did the big chart,
Mhm.
if n is like the number of observations, what do you put for xi, like total? That just the total?
There wasn't anything.
How did you get 52 for when you
Yeah.
where it says variance?
16 plus 4 plus 1 plus 1 plus 1 plus 4 plus 9 plus 16.
Oh, okay. So what is like the e symbol that you're multiplying by it and squaring it?
This?
Because like, wouldn't you square 52 after that then, or whatever?
No, that's the sum of the observations minus the mean squared, the sum of all of these. That E symbol means add all these up. Add
Oh,
all of the
okay.
standard deviations.
Oh, I see now. Thank you.
All right, check your understanding. It says in heights and inches of the 5 starters on a basketball team are blah, 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 blah. Find the mean, show your work. Y'all, I'm just gonna do it on one var stats. If you don't wanna do it, that's fine. I'm just gonna show you. We're gonna go into stat and edit. I taught you how to do this yesterday. So just kind of revamping. 67, 72, 76. If you have your calculators and you wanna do it, that's fine. I'm missing one, 67, 72, 276s. Doesn't matter what order you put them in. All right, stat, calc, one var stats, calculate it. All right, so what's our mean?
75.
75.
75. So we're looking for X bar is 75. I am not going to make you go through all this chart. You tell me which one is the standard deviation.
That's 6.244.
Uh-huh. So right here, it says show how to calculate it. Y'all, I'm not making you do all this. We're just going to do the standard deviation. And you said it's 6.24. And I'm going to go 3 decimal places, so 245. How would I find the variance?
Would you square the standard
Yeah.
deviation?
Yes. So to find standard deviation, I take the square root of the variance. To find the variance, I take the square of the standard deviation. And that would be 39-ish. And that gives you the variance. Okay, so this one was standard deviation. And this one is variance. All right, so here's the important one, guys. You're going to be doing this a lot. Interpret the standard deviation in this setting. So to interpret it, this is what it means. I told you the typical distance from the mean in context of the problem. What was our context? What were our data observations
The
from?
heights of 5 starters on a basketball team.
So the mean basketball players heights is 6.245, and tell me what unit it is.
Inches.
Inches. That's it.
I have a question.
Sure way.
Okay, this is probably a stupid question, but we're going to have the calculator the whole time on the exam, right?
Yes. That was your question?
Yeah.
Okay, so yeah, and what'll happen is I'll teach you how to do everything on the calculator, but you're also gonna have to write out your steps, not necessarily for the mean and the standard deviation, but you're gonna have to, like when we do big problems, which we're about to get into, you're going to have to list all the things out. So you have to label everything. So that's what people get a lot of points off for, is because they're too lazy to write things down. Not that it's hard writing, that they're too lazy to do it. All right, so I've already showed you numerical summaries with technology, so we're actually going to go down to choosing measures of center and spread. Okay, so we don't need to do that first part. I've already showed you. We now have a choice between two descriptions of center and spread. Of the distribution. We have the mean and standard deviation, or we called it X bar and S sub X. Because X bar and S sub X are sensitive to extreme observations, they can be misleading when the distribution is strongly skewed or has outliers. In these cases, we would use the median and IQR, which are both resistant. So again, a normal symmetric graph, we use the mean and standard deviation. Anything skewed, you're going to use mean and IQR. You do need to know that, okay? I'm going to keep saying it. You do need to know that. We'll see in the next chapter that the mean and standard deviation are the natural measures of center and spread. For a very important class of symmetric distributions, which are called the normal, and it's capitalized on purpose. Okay, that's how you'll see it in your book. They always make it like that. It's formal, the normal distribution. All right, so one more time, we're going to go over this one more time. You have to know this. Okay, that's a little star there. If we're doing it for a skewed distribution, what are we going to use?
Median and IQR.
So median and IQR are usually better than the mean and standard deviation for describing a skewed distribution with strong outliers. You're going to use mean and standard deviation Only for reasonably symmetric distributions that do not have outliers. Remember, outliers pull the data, so that's why it's skewed. Remember that a graph gives the best overall picture of a distribution. Numerical measures of center and spread report specific facts about a distribution, but they do not describe its entire shape. Numerical summaries do not highlight the presence of multiple peaks or clusters, for example. So always plot your data, and you will have to see that all the time. Always plot your data.
Could you use median and IQR for a symmetrical graph?
No,
Okay.
they will mark it wrong in a heartbeat. All right, so I have like 8 minutes left on this. I do want to finish these notes because there's only 2 more things to do. So 2 more pages, and this page will not take long. So what I'll do is try to get this page finished, and then we'll switch to a new screen, okay? So how to organize a statistics problem. This will last the entire semester, okay? This will last the entire semester. So your first step is to state. This is, what are you trying to answer? Your next step is to plan. How will you answer it? And again, you do this all year long. You're going to actually do it. So answer the problem. Here's the key though. This is where people hate stats. You have to show your work. You have to. It's not hard math, okay? It's not hard. You just got to show it. And then the last thing you're going to do is conclude. So finalize and give a conclusion statement. Many examples and exercises in this book will tell you to do what to do. You're going to construct a graph. Remember, I told you we do box plots. They're really easy to copy from the calculator. Perform a calculation. So state is what we're gonna try to answer. Plan is what you're gonna graph. You're gonna plan out your stuff. You're gonna calculate. That's in your do part, and then your interpret is gonna be your conclude. Real statistics problems don't come with such detailed instructions. From now on, you will encounter some examples and exercises that are more realistic. Use the 4-step process as a guide to solving these problems, as the following example illustrates. So I have like 6 minutes left on here, but I'm not going to try to push it. So let's go out and come back in, and I will finish that last problem. And I don't think it'll take 6 minutes, but just in case.